All right, let's now answer this question here. You might like to pause the video and see if you can do it for yourself on a rough piece of paper before giving it a crack. All right, let's now go through it. It says Sam takes out a $450,000 mortgage to buy his first home. The loan is charged interest at a rate of 4.9% per annum, compounding quarterly. He will pay this loan with quarterly repayments of $7,175. Let V of n be equal to the balance of the loan after n repayments. Write down a recursion relation to model this loan. All right, so what are we going to do here? Well, I'm going to say that V of 0, the initial amount of the loan, was $450,000. Then I'm going to go V of n plus 1 is going to be equal to, now I need to figure out what the R value is going to be. So it's going to be 1 plus, my R is going to be 4.9. I'm going to divide it by my compounding period, which is quarterly. So I divide it by 4 and then divide the whole thing by 100. So let's now do that on the calculator. I've got 4.9. I'm going to divide that by 4. And then I'm going to divide that by 100. And then I'm going to plus 1 to it. So that's going to leave me with 1.01225. And I think I'll just leave it unrounded. I'll leave it like that. So I'm going to get 1.01225, and I'm timesing that by V of n. And I also know that each quarter, I'm also making a payment of $7,175. So I'm going to subtract $7,175. So let's just talk about what each of these things mean. This is showing me how much I initially took out from the bank. This is showing me the amount of interest that is accruing on the loan each quarter. And this is showing how much I'm paying off each quarter as well. Before we move on, can we talk about the fact that the interest is being charged quarterly and the repayments I'm making are also quarterly. Both are quarterly. So too over here for the last example, the period of interest, so the compounding interest was monthly and my repayments were monthly. And that brings us to this note here, which says, in general maths, the number of compounding periods per year will be equal to the number of repayments made per year. That is, if interest is charged monthly, repayments will also be made monthly. So that's what that's getting at there. Okay, we have now done the first part, so we've created our recursion relation. And this says we need to use the recursion relation to find the value of the loan at the end of the first year. Okay, this is where we need to be careful. If it's at the end of the first year, that means I'm going to have to it's going to be 4 quarters, isn't it? 4 quarters. Because each year is made up of 4 quarters. So we start with V of 0. V of 0 is simply going to be 450,000. Then I'm going to go V of 1 is equal to, then I'm going to go 1.01225 times 450, and I'm going to have to zoom in here, otherwise it's going to get very, very ugly very quickly. 0, 0, 0 minus 71725, I believe it was. Am I correct? I am. No, I'm wrong. I'm wrong. 7175. My goodness, I can't remember a number from 2 seconds ago. Cool. So there it is. Let's now come to our CAS calculator and get it to do the heavy lifting for us. So we're starting with $450,000. And then I'm timesing that by 1.01225. Then I'm subtracting 7175 from that. And what I'm going to end up with is 448,337.5. Then I'm going to figure out V2, which is going to be 1.01225 times, this time is going to be 448,337.5 minus 7175, which is going to be equal to, hit enter, 446,654.63 ... Then I'm going to go V of 3. So this is now my third quarter, 1.01225 times 446,654.63 ... minus 7175, which is going to be equal to 444,951.15 ... And then in my fourth quarter, which will be the full year, I'm going to go 1.01225 times 444,951.15 ... minus 7175 is going to be equal to, my goodness, 443 226.805 dot dot dot. Okay, so having done all of that, and we can therefore say, therefore, value of the loan, or you could say the amount owing, value of loan after 1 year is money sign 443,226.81. Oh, there you go. That is how you do it. Hopefully that has made sense on how we have approached that question. Quite a bit of working there, but we had to show it because it said use the recursion relation to find the value of the loan after the first 4 years.